Okay.
All right, so tan theta is always going to be opposite over adjacent. Okay, you'll remember that. Doesn't change.
Okay.
All right, so tan 45 is going to be what? Opposite over adjacent, which is equal to A over B in our case. All right, over here.
Okay.
All right, it's A over B. Now, if you look at it very carefully, and I'm going to get rid of this little bit here because we don't need this information here. But I want to relate your gradient to what you told me earlier, which is the change in your y over the change in your x. Okay?
Okay.
All right. So if I get this point over here of the triangle, do you agree that this is some x value and some y value? All right? Okay, so that point there has got some x value and some y value. So what is the distance of this vertical segment?
The distance?
Yes. How big would this distance over here be?
I'd say...
Okay, remember that this is the origin. So if this coordinate over here is y of A, then how big is this distance over here? Now, let me do it this way. If I said to you that this y value over here was 5, can you tell me how much it is from the origin to this point over here?
4 units.
How big?
4 units.
4 units. Why do you say 4?
Because you start counting from the origin.
From the origin. So I'm going to go from the origin all the way to 5.
The 5.
So this would be 5 units. Okay, so this distance over here is just y of A minus 0 because the origin is where I started with. And what is this distance over here? If, and let's just erase our little 5 over here because that was just as an example. Let's say this is x of A. What is the x value at this point over here? Can you tell me what the x is over here?
What?
The x value. Okay, we're not getting that, so let's just go back. Let's go back here. I just want to do something with you. All right, Neo?
Yes.
Here's my Cartesian plane. If this is 0, and let's put the origin over here, okay? And let's say this point over here is the point 4, 2. Can you tell me what is the x value over here?
4.
What is the y value over there?
2.
That's 2. That's 4. How long is this distance over here? What is the distance between that and that?
3 units.
3 units. How do you get 3 units?
I start by counting from the origin.
But the origin is what? The origin starts at 0. The origin doesn't start at 1. Okay, so now I'm going to go 1, 2, 3, 4.
Okay, 4.
Okay, because you've done that twice now. You're counting from the origin, you're counting from 0. You're not counting from 1.
Okay.
All right. So if I said to you, this was 0 and this was 10, how long is this distance?
10.
How long is that? Is that 9 units?
No, 10.
Okay, why? Because we're starting from 0. From 0. And the origin is 0, not 1. Okay. All right. Let's go back to the question, which was on our next page. Sorry. Right, over here. Right, so I was asking you, if this is x of a, then what is the x value over here?
Oh,
This point here has got coordinates x of a, y of a. What is the x coordinate over here?
that will be y over a.
It will be?
Y over a.
No, it will be x of a.
Okay.
All right? Because the x
Okay.
value is the same everywhere along this perpendicular. So how long will this distance between 0 and x of a be?
If x is
It will be xa. Fantastic, okay? And this, because you are subtracting it from 0, will just be x of a. All right. So if we put all that together, we've got this over that, which was our opposite of our adjacent, and we now have sort of a new interpretation, really, which is not that much new, but it's just a consolidation, is that in this triangle here, this opposite over this adjacent is going to be y of a minus naught over x of a minus naught. And this formula here is actually the gradient. Okay, so in any Cartesian plane, the tan of the angle will always equal to the gradient that the line makes. Okay, now do you know what tan 45 equals?
let me check.
Tan 45 degrees is equal to?
1.
It's equal to the gradient. So tan 45 is equal to 1. So the gradient of the line will be 1. Okay.
1.
All right. Now, I just want to take that a little bit further. If you have a line that makes an angle of 135, right, then the definition for the gradient is that the gradient of that line will be equal to the tan of the angle. And the tan of that angle is equal to -1. So the gradient of this line will be -1. Now, this angle over here has got a special name. Okay, I'm going to give it to you, Nao, if you haven't come across it yet. And it's called the inclination.
Inclination, yeah.
Have you heard that before?
Yes.
Okay, the inclination is the angle that the line makes with the positive direction of the x-axis. And the inclination is any angle between 0 and 180 degrees. Okay, so lines that have got negative gradients will have obtuse angles. Okay, but a line that makes an acute angle will have a positive gradient. Okay, so just to conclude, we'll just write it up nicely. And this is what you've got to take away with you, is that the gradient of the line is equal to the tangent of the angle that the line makes with a positive direction. Will you remember that?
Yes.
Okay, so your question was, what is the gradient of a line that makes 45 degrees with that positive direction? You gave me another 3 questions. You said, what happens if it's 11? What happens if it's 73? What happens if it's 68? Doesn't matter what angle you're given, you will just substitute the angle into the tangent, and that will give you your gradient. Is that better, Nao?
Yes.
Are you sure?
Yeah.
Okay. Thanks very much for calling.
Keep this frequency clear. Keep this frequency clear.